Hey there, it's Gregory from Dapp University. So I've got another video tutorial for you today. I'm going to show you how to write an Ethereum smart contract step by step in your browser. All right, so before we get into that, be sure to subscribe to this channel if you haven't already and click the like button down below. And as always, if you want to learn how to become a highly paid blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. So today I want to show you how to create a token time lock with Ethereum smart contracts with the Solidity programming language. So what does that mean? Well, a token time lock is essentially like a savings account where you can put tokens for a specified amount of time, and it can't be released from this until a certain time in the future has passed. So they call it a time lock, okay? And I created a previous video on how to lock up Ether into a smart contract so that someone else couldn't withdraw it after a certain time. And today I'm going to show you how to do that with Ethereum-based tokens, okay? So what's the main difference? Well, Ether, or Ethereum, is the native cryptocurrency of the Ethereum blockchain, and tokens on Ethereum are basically other cryptocurrencies that are powered by smart contracts on the Ethereum blockchain. They're different from the native Ether cryptocurrency that runs the blockchain. Okay, and Ethereum allows you to create these tokens with an ERC-20 standard. I've got a link to that right here. Right, this just shows you how Ethereum-based tokens are created. I've got several tutorials on how to create Ethereum-based tokens, including how to code your own cryptocurrency on Ethereum and build your own ICO. So check that out if you haven't already. But today what I'm going to show you how to do is actually lock up tokens into a smart contract so they can't be touched until a future date. So some people call this token investing, and this is a really common thing to do in ICOs and other situations where you have money set aside for investors or other team members that can't be touched until a future date, okay? So I'm going to show you how to do this on your own. I'm going to teach you step by step how to create something like this, okay? So first I've got this file pulled up in Remix. This is remix.ethereum.org. And we're going to code all this in the browser step by step, okay? And we're going to start with this smart contract called the token time lock, okay? I've started off by declaring the version of Solidity that we're going to use. This is version 0.5.1, okay? And I've selected that current compiler version over here on the side, so make sure you've done that as well. And I'm going to create this token time lock smart contract like this. I'm going to start by declaring the contract with the contract keyword. Token time lock is the name, and then we'll put all the code inside these curly braces right here, okay? Now you'll also see this import statement, okay? So we're going to lock up some tokens. We're going to need a token in order to do this, right? But I want the focus of this tutorial to be on creating the time lock smart contract and not the token smart contract itself, okay? So I'm actually just importing a token smart contract here from this file browser, right? You can see other contracts here, so I'll go ahead and minimize that. But I've created another token.sol file inside this same project, okay? So you can actually get a link to this code in the description down below. I'll put a link. You'll be able to find all the files related to this tutorial and probably some other videos in this series as well. So just make sure you copy the token code in order to follow along, okay? And I actually show you how to build a token a lot like this in some of my other tutorials, and also including my blockchain developer bootcamp, okay? So let's go ahead and get started. What we're first going to do with this token time lock is create a place to store the token. So we'll do that with a state variable like this. Say token, public token, all right? And essentially that's going to be the smart contract address of the token that's deployed to the blockchain, right? So, Solidity requires us to declare the data type before we declare the state variable. So token here is actually the data type, which is defined here, right, with this contract, okay? And we'll set this value whenever we deploy the smart contract. I'll show you that in a minute. But this is essentially assigning the address to a state variable stored to the blockchain. So the smart contract address of the token will be written to the blockchain whenever we deploy it, and we'll be able to read that value from the smart contract because we declared this public, right? So Solidity gives us a reader function for free to read the value of our state variables whenever we declare them public. It means they're accessible outside the smart contract, okay? So now we want an address for who gets the tokens, right? We're going to call this the beneficiary. So we'll say address, public, beneficiary. And also we'll say the release time. UINT 256, public release time. All right, so that's 3 pieces of information. The cryptocurrency that we want to lock up, the person who's going to receive it once the time has passed, and then also the specific release time, okay? So the amount of tokens is actually going to be determined by the balance of this smart contract. And after we deploy it, we'll actually send some Ethereum tokens to this smart contract, and that's how they'll get released, okay? So let's set these values up whenever the contract gets deployed. So to do that, we're going to create a constructor function like this, constructor. And we'll say, inside this function, we'll call this public. We will set up the token, and we'll pass that value in. We'll just say token. All right, and so then we pass it in like this. Say token. All right. So we declare the data type, which is token, just like this. We pass it into the constructor, set it to the state variable here. All right, put a semicolon. We'll do the same thing for the beneficiary. And we'll say beneficiary. All right, and so we'll say beneficiary here. Address. All right, and then we'll also say release time. Okay. Release time. All right, perfect. So let's break this up a little bit. I'm going to format this code a little bit. Oops. We'll just do it like this. All right, one more. I'm going to format this so it's easier to see. All right, so here's the function keyword for constructor. Here's the visibility. Here's the code inside the function. Now, when we do this, we're also going to require that the release time is in the future. So the release time is going to be a timestamp in seconds. I'll show you that here in a minute. Okay, but we want to make sure it's in the future. So how do we do that? Well, we compare it to the timestamp on the current block like this. So you say block timestamp. All right, this is very similar to the other time lock that I created for Ether. You might have seen that in the previous tutorial. So this might look somewhat familiar, right? But we're doing this with the ERC-20 tokens instead of the Ethereum cryptocurrency, right? So now we're going to create a function to actually release this token whenever this date in the future has passed, okay? So do that like this. So say function release, and I'll say public. All right, so now we want to say basically release whatever tokens belong to this smart contract, release them to the beneficiary, so this person right here. So we're going to need to do some setup whenever we deploy this, but I'll show you how to do it. So we'll say uint 256 amount equals token. This is going to be the token right here, okay? And we're going to check the balance of this current smart contract. So we need to send this to some tokens later, but we'll check the balance. Balance of address, this. All right, so this is just referring to the smart contract, okay? And address is just making sure that this gets converted to an address type for the smart contract. And basically, we check the token balance to see how many tokens this smart contract actually has. And that's going to be the full amount that we release whenever we call release, okay? So balance of is just a function on this token. We'll go check that really quick. It basically just allows you to see how many tokens that this person has. Like, so you can see it here, right? Balance of, okay? So you can go check out my other tutorials on how to create ERC-20 tokens if you want to understand all this code. I figured I would just show you for now. All right, so now let's transfer the tokens. So we'll just say token transfer, and we'll say beneficiary and amount. All right, which we've stored amount here, and beneficiary we set whenever we deploy the contract here, right? Okay. All right, so transfer is also an ERC-20 function. We can go back and see that here. Here's transfer, right? It basically just sends the tokens from one account to another, and that's exactly what's happening. It's sending them from the time lock to the beneficiary, okay? So we want to add some more requirements inside here. Basically, we want to require that the block timestamp, right? So the current time on the blockchain basically is greater than or equal to the release time. Oops. Right, we want this to basically only happen once the tokens have vested or become mature, okay? And we also want to ensure that the amount is greater than 0. All right, we don't want them to perform this if it's basically don't have any tokens. All right. So I believe that is our full source code. All right. Go ahead and check that against the solution here. Let's just see. I'm going to pause. I'll let you pause the video and just check out the code at this point. Also, like I said, you can check out the full source code, the link below. All right. So you can pause your video and make sure this looks like exactly what you have. All right. So now let's deploy this. So we're going to do this in a few steps. Let's deploy the token first. So, well, actually, let's compile. All right. Compile. Token looks good. Token time lock, both look good. Go to the token, start to compile. All right, all good. So let's deploy the token first. I'm gonna go to run. I'm gonna choose the JavaScript virtual machine. This is basically gonna give us a blockchain that's already running in the browser. You don't have to have MetaMask installed or anything like that. You can just get started with your contract like this. All right, I'm gonna choose the first account on the list. It's already got 100 Ether applied. And I'm going to deploy the token. All right. So now, whenever we deployed the token, it gave the deployer a whole bunch of tokens. This looks like, maybe, let's say 1 million tokens. All right, I think so. So now what we want to do is deploy the time lock. All right. So let's do this. So let's go to the time lock. Go to compile it, and we will select the time lock. All right. And let's say the token, let's drop this down here. So the token address, okay. And let's copy it from here. So here's the deployed token. We can copy the address like this. All right. There we go. The beneficiary address. Let's see here. We want the beneficiary to be the second account. So let's go ahead and copy that. All right, and the release time is going to be a timestamp, okay? So basically the blockchain deals with Unix timestamps or the epoch timestamps. This is basically a time that computers use from a specified date. Basically, it's a certain number of seconds past this date in the past, which was in, I think, like 1970. It might be on the screen here. But anyways, that's how we read time on the blockchain. So we're going to copy this. This is in seconds. And I'm going to actually just increase this a little bit. So if it's 0.6, let's go 2.6, and we'll transact. All right. So we've successfully deployed the contract. Now we want to go back to the first account in the list and actually send them some tokens. So I'll go to the token time lock. We'll transfer 100 tokens. So we'll do 100, and then we have to use 18 zeros behind that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And we'll do it to the actual time lock. All right. So we'll create the time. We will copy the time lock address right here. All right. And I will paste it in and hit transact. All right, now the token has time. Now the time lock has tokens. So let's read some information from the time lock. Right. So the beneficiary is this account. So 160C. That's let's see here. This account here is let's see 160C. That's correct. Let's see here. The release time is this. And the token is this, okay? So I think we've already passed the release time here. Yeah, we're at 914, and this was at 826, so that took a little while. So we've already passed the release time. I know this works. I've tried it before, and I also did the, time lock and the Ether video, so I'm pretty confident that this is going to work. I'm not going to be able to test it on screen in the past anymore because I've already set the time. But let's go ahead and try to release it. So I can theoretically do it from any account in the list, but let's just go to the first account, all right? And I'm going to click release. All right, there we go, successful transaction. Now what I expect is for account number 2, right? This is the beneficiary. We want to check their balance, and they should have 100 tokens. All right, so we'll go to the token here, and let's see here. Let's get balance of, and hit there. All right, there we go. So that's 100 tokens. Now it looks kind of funny because there's 18 zeros behind 100, but it's the value we expect. Okay, so the reason it's got 18 zeros is because Ether has 18 decimal places, and you can see that here. Decimals 18. Basically, we have to put 18 decimals behind it because you don't store fractions on the blockchain for currency like this. So 18 decimals is sort of like saying, 18 units that it can be subdivided by, sort of like a really small penny. All right, so it worked. All right, guys, that's it. I'm going to put the description to this, the code for this smart contract down in the description below. Hope you all like this video. You can use this for your own tokens if you're holding ICO or want to, lock up any kind of money for any reason for a certain amount of time on the blockchain. Feel free to use this strategy, okay? All right, so I hope you all like this video. Again, subscribe to the channel if you haven't already. And if you want to learn how to become a highly paid blockchain developer, you need to join my free training on my website over at dappuniversity.com/bootcamp. And until next time, thanks for watching Dapp University.